limit as x goes to 5 of the square root of x minus the square root of x squared minus 4x divided by x squared minus 25. First thing we're going to do is try plugging a 5 in for each of the x's. That will give us the square root of 5 minus the square root of 5 squared minus 4 times 5 divided by 5 squared minus 25. So we will have the square root of 5 minus the square root of 5 squared, which is a 25, minus 4 times 5, which is a negative 20, over 5 squared, which is a 25, minus 25. So in the numerator, square root of 5 minus the square root of 25 minus 20, which is a 5, over 25 minus 25. So square root of 5 minus square root of 5 is a 0. 25 minus 25 is also a 0. We have the 0 over 0 indeterminate form. Since we have a root combination, a root involving the variable x in some way, added or subtracted together with at least one other term that's in the numerator here, we can try the root conjugate method. It turns out that we have two roots involving x, but that still has a root conjugate. You will just make opposite sign between the two roots for the conjugate, so we will have the root of x plus the root of x squared minus 4x. Other than that, you leave everything the same. Just change the sign between them. And we're going to multiply the numerator and denominator by that root conjugate. But we only FOIL out where we see the root conjugate pair, and that's in the numerator. We're going to FOIL that out. The first, root x times root x, is an x. The outside, root of x times the root of x squared minus 4x, will give us the root of x times x squared minus 4x. They can go together under the same root. The inside, the same thing but negative, because of the negative root of x squared minus 4x times a positive root of x. And then the last, which is the negative root of x squared minus 4x times the positive root of x squared minus 4x, will become a negative of x squared minus 4x. The most important thing is put parentheses around that, and the negative is going to distribute onto it. All this will be divided by what is not a root conjugate pair, and therefore we will not FOIL it out. We'll keep it multiplying in a factored version. So I just rewrite those multiplying each other. Whenever you multiply by a root conjugate, the outside and inside terms should always be equal value and opposite signs, so we can cancel those. Our next step is to be distributing that negative sign in. So we're going to do that onto each of these. So we have limit as x goes to 5 of x minus x squared plus 4x divided by x squared minus 25 times the root of x plus the root of x squared minus 4x. We can add together like terms in the numerator. We have an x and we have a positive 4x. Those can combine with each other. So we have the limit as x goes to 5 of 5x minus x squared divided by x squared minus 25 times root x plus the root of x squared minus 4x. Alright, so root conjugates do not eliminate the 0 over 0. They turn it into a new form which can then be reworked in some way, oftentimes power functions which will factor and cancel. We still have 0 over 0. I expect a factor of either 5 minus x or x minus 5 to appear in the numerator and denominator both, because x is going to a 5 here. The numerator is making 0 here, and the denominator is making 0 here. There's the two expressions we're going to be factoring. In the numerator, I'm going to factor out an x, a common factor, as well as a negative. And the reason I'm going to factor the negative is that should allow it to match what I will see in the denominator, because I have a difference of squares in the denominator. If I factor out a negative x, I will have a positive x and then a minus 5. And in the denominator here, I'm about to factor a difference of squares, which will factor into x plus 5 and x minus 5. And I factor out the negative, so I match the x minus 5. We're looking to always match those factors so that we can cancel them out. And then I have the roots adding each other. The x minus 5s can now cancel. We'll take those out. That should have eliminated the 0 over 0. And we have limit as x goes to 5 of negative x over x plus 5 times root x plus the root of x squared minus 4x. We can now try plugging 5 in for each of the x's. We'll have a negative 5 over 5 plus 5 times the square root of 5 plus the square root of 5 squared minus 4 times 5. That will give us negative 5 over 5 plus 5, which is a 10, times the square root of 5 plus the square root of 5 squared, which is a 25, minus 4 times a 5, which is a minus 20. The negative 5 and the 10 can partially cancel. That'll be a 2, that'll be a 1. So we're going to have a negative 1 divided by 2 times the square root of 5 plus the square root of 25 minus 20, which is a 5. So we have negative 1 divided by 2 times 2 root 5, and you have then negative 1 divided by 4 root 5.